Hi there, this is a short video on how to create a drawing from a part, which is similar to what you need to do for assignment 1 for DE 4301 Engineering CAD. So first thing to do is open the part. So we'll open that. This is something I've just created as a similar sort of example. A simple block with a few features. So we go File, Make Drawing from Part, choose a template. I've only got one showing, you may have a different screen, but effectively it's the same thing. And we want to choose the ISO A4 sheet. All good. Before we get going, we just tidy up this bit of a mess down here. So right mouse button click, edit sheet format, delete this because we're going to need the room in a minute, and drag that up so that it's off the title block. Double click on it, that'll enable us to drop the font size down to something reasonable, and we could change the text if we wanted to, but for the time being we'll just leave it as it is. Okay, then right mouse button again, edit sheet, and we're out of there. So now we need to place our views. So if we go to the view palette, need to refresh that just to show them. And for this drawing, the most detail is on the front view, so we'll choose that. And so we click on that, drag it over, drop it in the drawing space, and as we move our mouse up, it'll project automatically into third angle orthographic, assuming we've set the system up correctly in the first place, but we'll make that assumption. Now this is going to potentially give us a projected 3D view of this thing, but that's not what we want. We want the 3D view to be independent. So if we hit escape, when we finish there, those stick, and we'll just go and select again and select a isometric, drag that in, pop it up the corner there, and this is not quite the way we want it, so we'll change the display state, and also the scale is possibly a little large, so we use a custom scale and maybe make that 1:3. I'll just hit enter there, tick that, so that's okay. It's a pretty simple part, so it just gives an idea of what the thing looks like. Similarly, there's a bit much white space around these views, so if we click on the front elevation and do the same thing again, use a custom scale, and in this case we'll go to 1 to 1.5, and that should be okay. So I'll just drag these around a little bit to use the space as effectively as we can. That looks pretty okay. They will move independently, so on these axes, have to get the little arrow showing first, but yeah, so we can move that back and forth, but that looks pretty okay. So put some dimensions on. So we're in the annotation tab, smart dimension, and we'll put an overall width here. Now it's showing to 2 decimal places, which is a bit fine for something like this. So for this particular drawing we can change the settings, or you can change them as the default, but we'll just change these as required for this drawing. The more decimal places you show, the more its accuracy is indicated, and the more accuracy, the more cost. So always use the most, the least degree of accuracy that will be sufficient to make the thing useful. So we'll put an overall height or length, and that's probably all we can do here. We can also potentially put dimension here. The step, although maybe we won't do that. We'll put that here because it's actually more obvious and clearer if it's shown on that view. This is a little bit more obscure. Okay, so we'll need a height. And we need a height for the step. And straighten that out a little bit more. And we'll put our width here. Arrows in or arrows out, personal choice. If the size is very small, then obviously it's better to have the arrows out. In this case, I've put a leader out here off to one side so that it separates the number from the dimension somewhat. The rule is no dimensions on the part, and I think I'm just going to move this view over just a tad, just to give me a little bit more room there for clarity. Okay, so back to dimensioning. We need to locate the hole in both axes. And we'll need a diameter. SolidWorks knows if it's a full circle, that's a diameter. If it's a partial circle, it's a radius. We've got one of each here. And our slot will need a dimension or two, so we need a width. Just drop that down, make them a bit more the same. And we'll need a depth. And I think that's pretty much it. If we have a zoom down here, you would put your initials in there. We could go note, and there, a bit too big. And you might sign that if you were in a real workplace. We could put the date in there and so forth, and just do that using the note feature. Escape out of there, just position that so that it looks nice and tidy. And similarly, you can see here we've got overall tolerances, so unless otherwise specified. Therefore, if 28 doesn't mean much, but if we were to put a linear tolerance in there of plus or minus 0.5 of a millimeter, that applies to all the dimensions that are not toleranced, and in this case nothing's toleranced, so that would apply to everything, and that might be sufficient for this. If something were to fit in that bore, well then obviously that would need to be a tighter tolerance, and it would need to be some sort of fit, but we aren't there yet. We're just trying to lay out a drawing nicely, and I think that that is the job done, except for how do we upload it. So we'll save the file and call it something. And then file, save as a PDF. Save it again. Now I've got Acrobat Pro on this machine, so it automatically opens it. I'm not sure whether Reader does. You may have to go search for your file, so make sure you put it somewhere you can find it. And now that it's in a different color, it's actually useful to have another look at it, because you may see something that you didn't see before when it was in the SolidWorks screen. And with anything you upload, it's a good idea to check what you're sending to make sure that you've picked the right file and that it's as you would like to send it. So I'd be reasonably happy with that, and there ended the video. Hopefully it's been helpful.